Hello everyone, myself Assistant Professor Vatsal Patel from Civil Engineering Department working at Mahatma Gandhi Institute of Technical Education and Research Center NAVSARI. Today we are going to discuss about theodolite traversing and our today's topic is methods of traversing and its checks. Okay, so be ready with your pen and paper. So let us start with methods of traversing. So first of all, what is theodolite traversing? So let us understand it. So a traverse is a series of connected lines whose length and directions are measured in the field. The traversing in which traverse legs are measured by direct chaining on the ground and the traverse angle at every traverse station is measured with a theodolite is known as theodolite traversing. So this is the definition of theodolite traversing or say introduction. Okay, now let's see methods of traversing. So the following are the different methods of traversing. First one is fast angle or say magnetic bearing method. Second one is loose needle method. Third one is included angle method. Fourth one is direct angle method and fifth one is deflection angle method. Okay, so note down all these methods. Okay, now we are going to discuss it one by one. So first of all, fast angle method. So in this method, the magnetic meridian is established only at the starting station. This method is used to measure the magnetic bearings and length of traverse leg. Okay, so you can see its formation in the image. Okay, so the method is called the fast needle method as the vernier remains clamped with respect to the initial setting of the magnetic meridian. Okay, so be sure you remember it. Next is loose needle method. In the loose needle method, the direction of the magnetic meridian is established at each traverse station and the direction of the line is determined with reference to the magnetic meridian. In this method, the linear measurements are done with the help of chain or tape. It is also known as the free needle method. Okay, so remember it have mainly two names, so not be surprised if it is asked as free needle method in the examination. Okay, next is included angle method. This method is more accurate than the fast needle method. Traversing by the method of included angles is the most commonly used method. In this method, the magnetic bearing of any one line is measured in the field. So we can see in the image the bearing of the line at station is measured first and then after all the readings are taken. Okay, so it is like done like that. Next is direct angle method. This method is similar to the method of included angles. However, in this method, direct angle or the angles to the right are measured. This is generally used in open traverse. So here in image you can see that the measurements are measured at right angles. Okay, so direct angle or angles to the rights are measured in this method. Okay, on station right. Okay, next is deflection angle method. This method is suitable for open traverse and is mostly employed in the survey of rivers, coastline, roads, railways, canals, etc. Okay, so you can see it in the image. The angle initial bearing is here at station A. Then after some deflection will be there at station B. Okay, so to check that deflection, station C and station D are there, and the observation are taken and right deflection angle and left deflection angles are measured. Okay, so these are the 5 methods which are important for your examination. Okay, next is the most important topic. Okay, it is also important for the sum also. Okay, so next is closing error. So if the conditions of a closed towers are not satisfied, there is an error of closure due to the errors in field measurements of angles and lengths. Sometimes the finishing point may not coincide with the starting point of a closed towers. So the distance by which a traverse failed to close is known as closing error or error of closure. Okay. So let us understand it with one example. Okay. So here in image you can see one traverse. Okay. So you can see all the stations are mentioned here, but there are something missing. Okay, like if we see the traverse is here, like say A B C D A. Okay, but here is we have seen A1. Okay, so it is failed by the distance A1. Okay, the traverse is failed by closing distance A1, which is the closing error of this traverse. Okay, we have already shown here it is the closing error. So how we can find it? So here is one equation. So closing error AA1 is equal to under root sigma L square plus sigma D square. Okay, so equation, be sure you remember the equation, under root sigma L whole square plus sigma D whole square. Okay, where L is latitude and D is departure. Okay, so latitude and departure we will continue in the next part. Okay, or next slides. Okay, so then you will understand it better. Next, relative closing error is given by closing error divided by perimeter of the traverse. Next is permissible angular error. Least count into under root n, where n is the number of sides, and tan theta will be given by sigma d divided by sigma l, where theta indicates the direction of closing error. So from this equation and this all part we can find this closing error of these closed towers. Okay, so now let us discuss about latitude and departure. So topic is computation of latitude and departure. So the theodolite is not plotted according to interior angles or bearings. It is plotted by computing the latitude and departure of the point and then finding the independent coordinates of the point. So let us see latitude first. Okay, so its formation you can see in the image here. Latitude and departure both are shown here. Okay, so let us see it. So the latitude, or say it is denoted by capital L, of a line is its orthographic projection on the north to south axis, representing the meridian. Thus, the latitude of a line is the distance measured parallel to the north-south line. Okay, be sure you remember this point. So latitude L will be given by L cos theta. Small l will be there. Okay, L cos theta. Next is departure, or it is denoted by capital D. So same formation of here is in the image. Okay, so the departure of a line is its orthographic projection on the axis perpendicular to the meridian. Okay, first one is parallel, this one is perpendicular to the meridian. The perpendicular axis is also known as the east to west axis. Thus, the latitude of a line is the distance measured parallel to the east-west line. Okay, and departure D is given by L sin theta. Okay, so here we can see traverse, or say computation of all the signs. Okay, so let us understand what it says. So the latitudes and departure of lines are also expressed in the following way, like northing is equal to latitudes towards north, which is denoted by plus L. Southing, means latitude towards south, which is denoted by minus L. Easting, departure towards east, which is denoted by plus D. Westing, departure towards west, which is denoted by minus D. So from this it is very helpful when you do the sums. Okay, so be sure you remember this one also. Okay, it is very important. So note down this one also, it is important one. So let us see various conversion according to computation of latitude and departure. So first of all, conversion of WCB to RC reduced bearing, or say whole circle bearing to reduced bearing, WCB to RB. Okay, so when WCB will be between 0 degree and 90 degree, corresponding reduced bearing will be equal to the whole circle bearing, and its quadrant will be north east. Second one is 90 degree to 90 degree and 180 degree. Then reduced bearing will be given by 180 degree minus whole circle bearing, and its quadrant will be south east. Next is 180 degree and 270 degree. So reduced bearing will be given by WCB minus 180 degree, and its quadrant will be southwest. And the last one is 270 degree and 360 degree, and reduced bearing is given by 360 degree minus whole circle bearing, and its quadrant will be northwest. Okay, so be sure you remember this table. Okay, it is very important one, it is most useful for the sums. Okay, so be sure how you maintain all this conversion accurate. Okay, so this corresponding reduced bearing is given, these equations are very important. Okay, so note down this or note down this table. Okay, next is computing latitude and departure. Okay, so in first row you can see lines are mentioned, then length is mentioned, then reduced bearing in theta is measured. So latitude will be given by L cos theta and departure will be given by L sin theta. Okay, so according to that all the data are shown here, like reduced bearing will be n theta e north theta e, south theta west, and north theta west. And according to plus and minus sign, which we already seen, will be given by plus L cos theta, minus L cos theta, minus L cos theta, plus L cos theta. Okay, so it is also important one, so note down this one also. Next is computing consecutive coordinates. Okay, so there will be two terms here new in latitude, like northing and southing, and in departure easting and westing. Same scenario is here, this one is also here, only we have put the sign here. Okay, and remaining portion is written here. Okay, so there is a nominal changes. Okay, so this one is also important. Okay, so now let's see how can we check the closed towers. Okay, so check for closed towers is done by sum of northing equal to sum of southing, and sum of easting equal to sum of westing. So if the both check are accurate, then towers is said to be the closed towers. So let us see consecutive coordinates which we have seen here. Okay, consecutive coordinates. Okay, so the latitude and departure of a point calculated with reference to the preceding point for what are called consecutive coordinates. Independent coordinates. If coordinates of any point with respect to a common origin are said to be independent coordinates of that point, the origin may be a station of the survey or a point entirely outside the traverse. Okay, this is the difference between these two. Next, we are going to see check in closed traverse. Okay, so this error involved in traversing are two types, like error in linear measurement and error in angular measurements. So for check in closed and open traverse, first of all let us see check for the linear measurement, and then we will see check in closed and open traverse. Okay, so first of all let us see check for linear measurement. So our lines should be once each of two different days, like along opposite direction. Both measurement should tally. Okay, both measurements should tally after end of the day. Linear measurements should also be taken by stadia method. The measurement by chaining or by other method should tally. Okay, so in this all the values should tally first. Okay. Next is check for angular measurement. So the sum of measured interior angles should be equal to the twice n minus 4 into 90 degree, where small n is the number of sides of the traverse. Next, the sum of measured exterior angles should be equal to twice n plus 4 into 90 degree. And the algebraic sum of the deflection angle should be equal to the 360 degree. Next is check in open traverse. So in open traverse the measurement cannot be checked directly, but some field measurement can be taken to check the accuracy of the work. So there are mainly two methods, the line or say cutoff line, and second one is auxiliary point. So let us see the line or cutoff line. So cutoff lines are taken between some intermediate station of the open traverse. Suppose A, B, C, D here, A, B, C, D, E, F, G, A, B, C, D, E, F and G represent an open traverse, and let AD, this one, okay, cutoff line which is shown as the dotted one, okay, and DG be the cutoff lines. So the length and the magnetic of the cutoff lines are measured accurately. After plotting the traverse, the distances and bearings are noted from the map. These distances and bearings should tally with the actual record obtained from the field. Okay, so this is the procedure. Next is auxiliary point. Suppose A, B, C, D, E, F an open traverse here, this one. Okay, A, B, C, D, E, F, we can see it is open traverse. Okay, so a permanent point P, capital P, is selected on the side of it, and the magnetic bearings of these points are taken from the traverse stations A, B, C, D, etc. Like P will be here, and all the bearings are taken like this. Okay, towards P. Okay, so if the survey carried out accurately and so is the plotting, all the measured bearings of point P, say capital P, when plotted should meet at the point P. Okay, so the permanent point P is known as the auxiliary point, this one. After plotting all the data, if they match at one point, this final point P is known as auxiliary point. So these are the two methods. Next is also important one, balancing of traverse. So be sure you read it carefully and understand it carefully. Okay, so a traverse is balanced by applying correction to the latitudes and departure. This is called balancing a traverse. In case of closed traverse, the algebraic sum of latitudes and departure must be equal to 0. Okay, it is most important for sum also. Okay, so be sure you remember it very well. In other words, the sum of northing must be equal that of the southing, and the sum of easting must be the same as that of the westing. But in actual practice, some closing error is always found to exist while computing the latitude and departure of the traverse station. So, the total errors in latitude and departures are determined. These errors are then distributed among the traverse station proportionately according to the following rule. There are mainly three rules: Bowditch rules, transit rules, and third rule. So let us understand each and every rules and let's see how it is done. So first one is Bowditch rule. The Bowditch rules, also termed as compass rule. It is mostly used to balance traverse when linear and angular measurements are equally precise. By this rule, the total error in latitude or departure is distributed in proportion to the length of the traverse leg. This is the most common method of traverse adjustment. So it is given by the equation. Okay, so let us see its equation. So correction to latitude of any line, it is given by length of that line divided by perimeter of traverse into total error in latitude. And correction to departure of any line is given by length of that line divided by perimeter of the traverse into total error in departure. Okay, so be sure you write down all this equation as well, because it is also important for the sum. Okay, so make sure you write down all the equation, okay, which we will discuss continually. Next is transit rule. The transit rule is used to balance a traverse in which the angular measurements are more precise than the linear measurement, or say theodolite traversing. Okay, so it is mainly used for theodolite traversing. So in transit rule, correction to latitude of any line is given by latitude of that line divided by arithmetic sum of all latitudes into total error in latitude, and correction to departure of any line is given by latitude of that line divided by arithmetic sum of all departure into total error in departure. Okay, so note down this one also. And the last one is third rule. If the correction are to be applied separately, then the third rule may be used. Okay, so correction to northing of any line, okay, it is given by northing of that line divided by sum of northings into 1/2 in total error in latitude. Okay, correction to southing of any line is given by southing of that line divided by sum of southing into 1/2 total error in latitude. Next, correction to easting of any line is given by easting of that line divided by sum of eastings into 1/2 total error in departure. And correction to wasting of any line is given by wasting of that line divided by sum of wastings into 1/2 total error in departure. So I hope you have noted down all the equation. Okay, it is very important, so note down each and every equation. Okay, next we are going to understand Gale-Travers table, which is very important for your practical work. Okay, and it is also important for the sum. Okay, so Travers computation are usually done in a tabular form. Okay, one such form is Gale-Travers table, and it is widely used because of its simplicity. It provides a systematic method of recording the computations of the traverse. Okay, so let us see here the closed tower A, B, C, D is here. Okay, so for procedure used to recording the computation of closed towers A, B, C, D in the Gale-Travers table, this one. Okay, we are going to see. Okay, or understand. So here is the Gale-Travers table. Okay, so let us see how we can write all the data in this one. Okay, so step by step I will explain you the table here. Okay, so first of all, first point is write the name of traverse station in column 1 of the table. For example, A, B, C, etc. Okay, so here number 1 is given, okay, at the top corner of the table. Okay, so in this column we have to write the names of traverse station, and it will be the capital one like A, B or C. Okay, so it is also we have not down here instrument station. Okay, next step is write the names of traverse line in column 5, number 5. Okay, column 5. Okay, of the table. For example, A, B, B, C, C, D, etc. Okay, so if we are writing the traverse lines name, okay, so we should write it in the column 5, and it will be like capital A, B, B, C, C, D. Okay, A, B, B, C, C, D, etc. Okay, next write the lengths of the various lines in column 6. Okay, so some length will be there, okay, say in meter, so write down its length in column 6 here. Okay, next write the angles in column 2 here. Observe angle we have mentioned here. Okay, so angles should be write in column 2, so sum of all the angles entered in column 2. Okay, so here at the last we can see total is here. Okay, so we have to do sum here. Okay, so the sum of the included angles should be twice n minus 4 into 90 degree, which we have already discussed in this lecture. Okay, where n is equal to number of line. Okay, and for ordinary traverse equal corrections are generally applied to all angles. Okay, or say if any error will be there, it is divided in all the correction angles. Okay, next, enter corrections in column 3. Okay, so we have mentioned correction to each and every angle. So line, okay, so correction will be written here, okay, in column 3. Next, write the corrected angle in column number 4. Here corrected angle we have written, okay, so corrected angle will be written in column number 4. Okay, so starting from the observed bearing of the initial line, or say AB, in this case calculate the bearing of all other lines from the corrected angles. Okay, next, enter the whole circle bearings in column 7, or say we denote it with WCB. Okay, we have here. Okay, so it will be written in column 7. Next, obtain the reduced bearing from the WCB, or say whole circle bearing, and enter in the column 8. Okay, so reduced bearing is here. Okay, so already we have seen the conversion of it in the table. Okay, and I have already told you that it is very important. Make sure you note down that and remember that. Okay, so according to that, obtain the reduced bearing from the whole circle bearing and enter in column number 8. Okay, here, and enter the quadrants of the reduced bearing in column 9. Okay, so quadrant will be written in column 9. Okay, okay, so I think we have discussed all these things. Okay, and next 11, 12, 13, 14 and 15, we have already discussed it, all the consecutive coordinate correction and corrected consecutive coordinates, which is done according to the equation which we have already seen. Also table we have also seen. Okay, so it is very important for your examination. Okay, so be sure you understand it very clearly, because it is most useful for practical work. Okay, so it is the main one, so be sure you understand it very well. Okay, so here is the procedure. I have already discussed this one. Okay, so here is the procedure, so you can note down step by step. Okay, and according to that you can write down. Okay, so here is the procedure. Okay, so here are some important questions which is very useful for your examination, and these parts is very important. Okay, it is mainly asked in your examination, so these 3 theories is most important. So be sure you understand it very clearly, and make sure you write these questions for your examination. Okay, so it is very important. So here I end my session. Thank you all of you.